Hello and welcome to a new video on IGCSE Physics Classified Paper 2. In this video, we shall be discussing the topic of echo and speed of sound. We'll begin with conceptual questions. The sound from a loudspeaker must pass through two materials to reach a microphone. Which combination of materials gives the shortest time for sound to reach the microphone? You should know that sound is capable of traveling through air or gases in general, water or liquids in general, and solids. But sound travels fastest in solids. And an interesting piece of information is that long ago, when two armies were at war with each other, people would put their ears to the ground in order to listen to the distant hoofbeats of the horses of the opposing army to estimate how far the opposing army was. So in order to estimate when they're going to arrive, maybe in one day, maybe in 2 days, the experienced soldiers would put their ears to the ground. And because sound travels so much faster across solids, through solids, they could estimate from the intensity of the sound of the hoofbeats of the horses how far the opposing army was. So this is a nice example just to remind you that sound travels much faster in solids than it does in liquids and even slower in gases. So for the shortest time, we will go with the option that has the two solids, which is choice C, copper and aluminum. A girl notices that when she shouts into a cave, she hears an echo. Which wave property causes echo? This is something you must know. Echo is caused by the reflection of sound waves. So you have a girl and you have a wall and she shouts or she speaks or whatever. The sound waves hit the wall and come back. And that's why she hears the echo. So C is the correct answer. The speed of sound in air is 330 meters per second. The speed of ultraviolet waves in air is 300 million meters per second. Which row gives a possible frequency and speed of ultrasound waves in air? So this is very important. They're basically trying to trick you because ultrasound basically has two components, right? The part that says ultra and the part that says sound. So is ultrasound closer to ultraviolet or is it closer to sound? It has absolutely nothing to do with ultraviolet. Ultrasound is a sort of wave or a type of wave that is very close to sound waves. The only difference is that it has a frequency greater than that of sound. So what is the frequency of sound waves? From another video, you should know that the frequency of sound waves is between 20 hertz and 20,000 hertz. This is the range of human hearing. This is the sound that we can hear. Ultrasound has a greater frequency than this number. That's why we cannot hear ultrasound, unlike bats, which communicate together via ultrasound. So the frequency must be greater than 20,000, and we ignore these two. As for the speed, it's similar to the speed of sound. So it's something close to 330. So definitely not the ultraviolet speed, not the 300 million. So we're just going to go with C, higher frequency than sound, but same speed. So this is the correct choice, choice C. Which wavefront is traveling at a speed closest to that of a sound wave through a solid? Now, just as a rough estimation, the speed of sound in air is 330 meters per second. Roughly. If you want to get the speed of sound in liquids, just an average estimation, it varies from liquid to liquid and it varies from gas to gas. But I found that a nice way for estimating is just to multiply by 4. So from here to there, multiply by 4. From here to there, multiply by 4. And you're going to get nice estimates for the range of speeds of sound. So let's multiply 330 by 4. That gives us 1,320. Let's multiply that by 4 again. That gives us 5,280. So, oh, I'm very sorry, excuse me, I made a mistake. It's the other way around because we said that solids have the, excuse me, I'm so sorry. This is not gas, this is solid, I'm sorry. This is solids, yeah. I made a mistake, I apologize. Air, by air, I mean air or any gas, right? So air is 330, liquids, we multiply by 4, and then for solids, we multiply by 4 again, so roughly 5,280. So we want something traveling through a solid. We want a speed that is close to the speed of sound in solids. So let's figure out the speed in each of the cases and compare. Remember that speed is equal to distance over time. This is like the very basic representation of speed. So if we divide, so 10 divided 0.01 is 1,000. 50 divided 0.5, this is 100. 1,000 divided by 100, this is 10. 2,000 divided by 2,000, this is 1. So what is the closest to that of a sound wave through a solid? Of course, it's the highest speed, right? So the highest speed here is A, and this is the closest to the speed in a solid. Different waves travel through air. Which waves have the greatest difference in speed? So you need to know that electromagnetic waves include ultraviolet waves, light waves, and radio waves. These are not within the scope of this video. These have to do with another video that has to do with light and electromagnetic waves. But ultraviolet waves and light waves and radio waves, these all have a speed of 3 times 10 to the power of 8 meters per second. 300 million meters per second. And we saw this number in a previous question in this video for ultraviolet. So these have the same speed. So we want a greatest difference in speed. So definitely not C, definitely not D. What about A and B? Ultrasound and sound have roughly the same speed as well, which is around 330 meters per second. So the only choice that has a very big difference between the two is ultrasound and ultraviolet. And they're trying to confuse you because you have ultra, the word ultra in both. So you might feel that they have the same speed, ultra, so it's very high speed. But that's not true. Ultrasound is very slow, ultraviolet is very fast. So the greatest difference lies between ultrasound and ultraviolet. So the correct choice here would be choice B. Moving on. The speed of sound is different in different states of matter. The speed of sound in water is 1,500. Which row correctly compares the speed of sound in ice and the speed of sound in steam with the speed of sound in water? Of course, in ice, it will be faster. In steam, it will be slower. So this is an easy question. The correct choice is C. A sound wave travels from a medium in one state into the same medium, but in another state. This causes the speed of the wave to change from approximately 300 meters per second to approximately 3,000 meters per second. Between which two states is the sound wave traveling? So the speed is increasing. So first of all, we know that it goes from gas to liquid to solid, because we said that solid has the highest speed. So anything moving in this direction is correct, either from gas to liquid, or from liquid to solid, or maybe even from gas to solid. So let's eliminate what we definitely know is wrong. So liquid to gas is definitely wrong, and solid to liquid is definitely wrong. Is it gas to solid or liquid to solid? They both seem to be in the same direction. But the distinction between them is basically the number they gave you for the initial state. We know that the speed of sound in air is 330. So 300 is a very small number for a liquid. So the initial state was definitely gas because the speed of sound was 300 meters per second. So we're going to go with gas to solve. Next, we move on to questions that require calculations. A man holding a starting pistol stands 640 meters away from a spectator. The spectator hears the sound of the starting pistol 2 seconds after seeing the flash from the pistol. What is the speed of sound in air? Of course, this is very simple. The speed of sound is the distance over the time, and you just divide 640 by 2, and that gives you 320 meters per second, which we know to be the closest value to the speed of sound in air, which we normally describe as 330 meters per second. So B is the correct answer here. A pulse of sound is produced at the bottom of a boat. The sound travels through the water and is reflected from the seabed. The sound reaches the boat again after 1.2 seconds. The speed of the sound in water is 1,500. How far below the bottom of the boat is the seabed? So this has to do with a bit of an echo. There is a reflection involved, and you must be very careful as to whether you're going to use the distance or double the distance. And what do I mean by that? In this case, for example, for the sound to reach the boat again, it must have traveled all the way down, hit the seabed, and then traveled all the way back up. And we know that the time taken is 1.2, and the speed is 1,500. So this is V, and this is T. So the distance traveled by the sound is equal to Vt. And this number is equal to 1,500 multiplied by 1.2. And that gives us 1,800. But is this the distance we're looking for? This is the distance traveled by the sound. And this involves going down and going up. But we want the distance between the seabed and the boat. How far below the bottom of the boat is the seabed? So we just want one of these. So basically, we divide by 2. We have 900 down and 900 up. Because 1,800 includes both down and up. So just to get one of the pair, just one trip, we just will divide by 2, and we get 900. So this is the distance we're looking for. So you must be careful when you have a reflection of sound as to whether you need to multiply the distance by 2 or divide the distance by 2 or keep the distance as it is. Just using D equals Vt is not always enough. Here we had to divide by 2. So B is the correct answer. A man stands 110 meters from a high wall. He makes a short, sharp sound and then hears an echo. The speed of sound in air is 330. How long after making the sound does the man hear the echo? It would be nice to draw a simple drawing to understand the problem. So you have a man who's shouting, and this distance here is 110. And the speed, so D equals 110 here, and the speed is 330. So this is V. And we want the time. So let's first just use the equation. If we have D equals Vt, we can rearrange that to T equals D over V. So the time here is going to be 110 over 330. But again, we need to figure out whether we're going to use the distance as it is or multiply it by 2 or divided by 2. And this has to be understood from the context of the problem. So we want the man to hear the echo. So we want the sound to travel from the man to the wall and back. So in this case, our distance is not supposed to be just 110, but we need to multiply it by 2 in order to figure out the true time. And if you perform this calculation, you're going to get 0.67 seconds. So the correct choice here is choice B. A student stands 180 meters in front of a vertical flat cliff and bangs together 2 pieces of wood to make a short, loud sound. A timer records the echo of the sound 1.5 seconds after the pieces of wood are banged together. Based on this result, what is the speed of sound? So again, we have student and the wall, and this distance here is 180. And the time in this case is 1.5 seconds. So the time includes the time for sound to go to the wall and back. So in this case, we want to multiply the distance by 2. So let's use the equation d equals vt. In this case, we're trying to get the speed. So let's rewrite it as v equals d over t. And for d, like we said, we're not going to use 180 as it is. We're going to multiply it by 2 and then divide by 1.5 for the time. So the answer is 240. Correct choice here would be choice B. The student finds that it takes the sound 0.33 seconds to travel 100 meters. In this case, there is no echo, there is no reflection, so we don't need to do anything to the distance. We want to get the speed, so we just use d equals vt. And we want v, so v equals d over t. And that's basically 100 divided 0.33. Let's try that out. That's 303. So the closest answer here is 300 meters per second. And this brings us to the end of our video. I hope this was useful to you. Thank you for watching.